So let's go to the Scala test, which I have renamed it to Rover test. So that makes a lot more sense. So let's zoom in so that we can see what we're doing. We now have rotate right commands, and we now have the left commands. So now we're getting the structure. So notice here, I'm actually outputting the position. So the position where on the actual grid is 0, 0 Cartesian coordinate, starting from the top left hand corner of the grid. We're facing east, and then the corresponding rotate left commands, which is a private val here. I've still kept the original sort of test to prove out the point here, but we could get rid of these quite easily because everything is in the parameterized test. So let's go to the implementation. Implementation is again very straightforward. We still have a string direction, and this time we've added rotate right here, and rotate right is the mirror of rotate left, and that's it. So let's run these tests again, and we should see some nice output here. The corresponding output, you've got the rotate right, and now you've got the rotate left, and that's really good. So how have I implemented the positions? So as you see here, I've started to add x and y as coordinate variables. And if you examine the code here, I'm using string interpolation in the execute function to return the actual position and the facing direction of the rover. And it is still readable. You see, my test is, and I spent a long time contracting, moving from companies to company. When you look at a code, can I understand this code 3 months later? At least 3 months later, because you're going to be working perhaps on a different part of the business. And then if you come back and it's a mess and you can't understand just by inspection, just readability. So the hardest thing in computer science is naming things. So look at how I programmed the name things: rotate left, rotate right, direction, no shortening, hardly. I probably do have an abbreviation, but I keep it to an absolute minimum. There are some errors here, like command and command char, and you will make these kind of mistakes. Do not worry about those mistakes. The main thing is that these can be fixed during refactoring and a code review. That's why we pair, right? We pair so that we share knowledge and you get that instant code review. Let's move on to the next thing, which is adding enumerations. Before we add enumerations, let's look at moving this rover across the planet Mars. And I have done so already. So you know this, the table-driven property checks. So we've got rotate right and rotate left commands. So now I've added a bunch of move commands. So this is the ability to move the rover and then move the rover again with these. Again, a new set of parameterized tests called move commands. And now it starts to make a lot of sense why we've added the member variables here, integers x and y, and a direction. And we can solve a few more things. So in the original problem, there is a grid of squares or cells or whatever it is. So let's look at grid first of all. So grid is really quite simple here. It's meant to represent a grid of rows and columns. There's nothing in it quite yet. And this shows you a case class or a data class in Kotlin. Really quite straightforward, as simple as can be, or record in Java 17. Okay, so interesting thing here. In the move, you have to take care of, so grid is a private instant member of the rover. So the rover has a grid, and therefore you need to know when the rover is moving off the grid. So let's start with moving north. If you're moving north, and we reverse the Cartesian coordinates normally, if you move above the height of the grid, then you wrap around to the lowest, to the southern part of the grid. Same rise, if you move east past the eastern part of the grid, past the maximum column, you rotate and wrap around to the western side. So x equals 0, as in the Cartesian coordinate. Same rise with the rest. If you move off the western part of the grid, which is you have a coordinate of -1 or negative coordinate, then you have your column should be the maximum column -1. Same with moving south. If you move past the southern part of the grid and you end up with a y negative coordinate, you should be on the maximum row coordinate -1. The maximum amount of rows -1. And that's it. That is generally the move command. So if I go back to the execute function here, you'll notice that if it's a left command, rotate left. If it's a right command, R, rotate right. If it's an M command, move wherever. And there's still a mistake here, a deliberate mistake that a code review would chomp down on. But I'm being very polite because I want to see if you, and I'm be the hiring manager, can figure out how to solve the problem. So this is a hint for code reviewers. Sometimes don't become pernickety or pedantic because it interrupts thought. You want to see how your guy or your prospective new gal is going to work inside a company. So don't breathe fire. Interviews are nervous enough. Just chill, man. Just ease up, Naaya. Anyway, now we can run the tests and let's see what happens. Surprise, surprise. All of the tests are working exceptionally fine, including the ones where we are moving. So let's go back to the Scala test here and go to our list of positions. So now, if you can see, we have the move command. So we're facing north. Oh yeah, I forgot to mention the first tuple defines the column names. So in my Scala test explanation of the parameterized test, actually you always need n+1 because the first row in the tuple is the description. So this is an easy mistake in Scala test, in a parameterized test. You can look up the manual. Finally, we've proven that it works. Let's now go and implement that enumeration. Okay, we're back with the SBT file. So now we have the same Scala test. Okay, we're back to the SBT. Nothing has changed. Let's go to the Scala test here. We still have our move commands, and actually we've got wraparounds now. I've added these wraparounds. As you can see, the grid size is 10, and now I've added directions. So a word on Scala 2's directions. So it's really quite straightforward. Yeah, this is tricky. And I don't expect, I don't expect you to actually implement this in a online review or Zoom review. What I probably would do was give you this class, or send this class to you in the chat and see how you would cope with it, because there's a lot of difference between Scala 2 enumerations and Scala 3. You can see here that I've added some really nice things, value to direction, take a value, and then a short name to a direction. And it's complicated. You'd need to look up line or just ask me on Twitter or on LinkedIn or wherever on social media if you've got questions. Okay, so let's look at the tests. So I've got a couple of tests to demonstrate some of the mapping. So like short name to direction, that means I can turn the character N into a direction because I need this. What else is there? I can print out the short name if it's unknown. So retrieve enumeration with unknown short name. That's a failing test that proves that you've got a rubbish short name. That should be returning a no, which it does. And I've got my commands to move a rover and the same parameterized test. So I think I've removed the original test. So if I go to the rover now, I have replaced the original string direction with direction enumeration, and now I've actually fixed the actual functions themselves. Remember that parameter, the unnecessary mistake? I realized we didn't need these, so now we've just got rotate right, no arguments, and rotate left, no arguments, and move with no arguments. And it looks like code that we have before. So there we go. We have therefore an enumeration, and we still have our grid. So if I run this test now, everything should be hunky-dory. And indeed it works.